Hello friends, welcome to my channel. So in this video, we are going to have a look at problem 1915, number of wonderful substrings. This problem actually is a very interesting problem. This problem can be regarded as a development or variant of problem 560. Subarray sum equals to key. For example, find some subarrays with sum equal to 0 when k equals 0, right? So in order to get a better understanding out of this video, you can first review the video for problem 560 and some related videos to that problem. So basically you can regard this problem 560 as the prototype of such problems, and then the big ideas will be the same. So now let's look at the problem here. So we want to count the number of wonderful strings, right? So this is the counting problem. So here the definition for a wonderful string is a string where at most one letter appears an odd number of times. So in other words, so we allow one letter to appear odd number of times. All the other letters should appear even number of times. So here are several examples. So in example 1, you see ABA, the output is 4. And in the second one, the output is none. So here actually it lists all the possibilities. But in the later analysis, we'll try to think or reasoning in an abstract fashion. Because sometimes when you write code or when you think about coding, so the certain level of abstraction is very important. And not only in coding, but also similar in mathematics, right? So in example 3, so the output is 2. So we can only choose two H and E as two substrings, right? So here the constraints are the following. First, the length of this word or string is bounded above by 10 to the power 5, but it can be as long as 10 to the power 5. In other words, time complexity will be crucial for this problem. And the second example is also very important. So this word consists of lowercase English letters from A to G. So from A to G, there are 10 letters, right? So this basically tells us we at most need to check this 10 unique letters. So this will play a role. Actually, we can regard this problem one step further from simple counting, like in problem 560, right? So with that said, let's look at the analysis. So here, so in this problem 560, we think of prefix sums or partial sums. So in this problem here, in order to solve it, we consider prefix exclusive OR. So here, if a letter appears in even number of times, so if we use the index of that letter as a bit position, then that bit position should have 0, right? If you do exclusive OR, due to the definition of exclusive OR. If we have 1 and 1, so you're going to result in 0. All the other cases result in 1. So here the big picture is the following. So we are going to count substrings in which all characters appear even number of times. And then later we just need to flip one character in the above strings. Then this there will be at most one character appearing odd number of times. Then we count them. Then the sum in step 1 and step 2 will be the right count. So the thing is how to do the counting. That's the main point in the first item. So basically, if we assume we record the prefix OR, exclusive OR for up to index I, for example, this is the A0, A1 up to AI. Let's call it this prefix OR result, exclusive OR result, it will be A. So if prefix X at the earlier index, the CI0, they also have this XOR result. And then it means that from index I0 plus 1 ending at I, so this has exclusive OR result 0, right? This means that for this substring, starting from index I0 plus 1 ending at I. So all the letters in this string, in this substring, appears even number of times. So this can be easily seen, right? So you do prefix exclusive all up to index I, and then do with exclusive all with up to I0. So here you from A0 to I0 up to AI. So the last one is from A0 up to AI0, right? So the first part, this two, cancels. The reason is that if a number exclusive all with itself, you're going to get 0. Then we get this part. Because this is the A exclusive all with A, so it means 0. So that's why we have this exclusive all result is 0. So then we can do the counting. So we can do the counting exactly like in problem 560, right? If you know that problem, then solving this problem shouldn't be very hard. So now let's look at the coding, and then we can maybe have a look at example 1, right? First, let me initialize the variable answer. So this is the counting variable, right? Count the number of wonderful substrings. So we are going to return its final state. So we have a prefix exclusive all. We are going to start from 0. This is natural, right? Then we have a dictionary. So let's call it count. So we count a result. So for this, we assume empty. We assume it's 0. So it appears once. So here, this is the exclusive all result, and its frequency. It means that this exclusive all result appears this number of times, right? And then we are going to do the for loop. So for character in word, then what we are going to do, first we are going to do prefix exclude all with the current character, right? So here, when we do this, because we have 10 letters, so we are going to use bit mask. So we are going to use 10 positions. So this is the one position, and then let's say you have 10 positions, right? So I'm going to use this one as a bit for A, or this one is bit for B. So this one bit for C. So this, for example, this is index 0, this is index 1, this is index 2, right? So then what I'm going to do is that if that character appears, right? So what we are going to do is exclusive all with this one. So the ordinal number of this character minus this ordinal number of character A, right? So this means if this character is A, so you are going to get index 0. If this is the B, you are going to get index 1. So 1 shift left to this number. So this means, so if you have 1 shift to left, say n times, so it means 2 to the power n, right? So this is just a fancier writing format, or just using bit-wise operations. So once we have this, we should check if this prefix has appeared, how many times, and then this will correspond to this kind of format. This is substrings, number of substrings that all the letters appear even number of times. So first, let's count this. Count substrings with all unique letter appearing even number of times. So this is for sure wonderful, right? So this we have answer increment by. So we are going to do count get this key prefix. Otherwise, we have 0, right? So then we also need to if we change 1 position, and then we still we are going to get different prefix sums. Then what we are going to do is to check if those prefix sums also appear in this dictionary. If so, we are going to have those wonderful substrings that's corresponding to count substrings with at most, or actually one letter, one unique letter appear in odd number of times. So this can be done. So we can use a list comprehension as comprehension sum. So we can't get. So we'll get which one? So prefix going to exclusive all with I, right? So here I'm because we so here this part we check this this sum. If it's not there, so we're going to have let me do it again. So we get prefix so exclusive all with 1 to the power I, right? So if not, we're going to have 0. So this is for I in range 10, because we have 10 letters by this assumption, as we mentioned before, right? So A corresponding to 0 and J corresponding to none. So this way we count those wonderful strings, and then so we need to also update the prefix in to go to next round in the loop. So what we are going to do, because up to here, right, this prefix appears once more, right? So this will be count. So the prefix is equals count get prefix. If it does not appear, we have 0. That's plus 1, right? Then we just need to return the answer. So this is the a solution format to this problem, right? So let's do a quick check. So we have ABA. It passes the first example. Then you can submit this. Yeah, it passes all the cases. So in order to better understand this, for example, you can print out all those things, right? So for example, you can print the prefix. So this is the prefix XOR result, right? Then so we let's see. After this two, so we can just print 1, I guess. So let's see, print answer before counting or incrementing, right? So this is just the answer. So then I can copy this part. So answer after counting, right? Then you can also print the final state of count. Let's do this, right? So at the verb, let's also print some space. When you look at the letter A, right? So you have original answer is 1, and then A is a valid one, right? You have 1. So then if you look at B, so because A is 0, 1, and B is 1, 0, you get 1, 1, that is 3, right? So the answer before counting is 1, then after counting is I'll have 2, right? So then you look at this A, so 3, so exclusive all with 3 is 1, 1, with 0, 1, you get 1, 0, that is 2, right? Then the answer before counting is this 2, right? Afterwards you get 4. So here actually this A itself is a valid one. Also starting from the first A, ABA is also a valid one, that's the 4, right? So you can see also the state of this this dictionary. Then you can give a walkthrough by yourself. So I'm going to comment out those print. and submit again so that we can see it's more clean. So with that said, I guess that's about it for this problem. So I would strongly suggest that you have a look at the video for problem 560 in order to better digest the logic here and the thought process. And it would be even better if you can check out the videos related to problem 560. This way it will help you establish a sort of pattern later when you meet this kind of problem, you quickly reflect. So with that said, I guess that's about it for the current video. Thank you for watching.